So let's get on to the algorithm, and we'll be going through all the lines and what works, like what is done here. So let's get started. So first of all, this is the function that we are calling. It's taking a parameter g. So what g represents is a vertex and an edge. So we have 4 vertices here and many edges. So that's the input of that function. So here we have like some terms which are not easy to understand at first glance. So that's why I have explained all of them. Anyway, so for each vertex you epsilon vg. So this whole thing means that we are initializing the arrays. So at first we would have a color array and a pi u. So pi represents a parent array. So we have written 2 arrays here. So we are initializing. So let's write these down. So all of them would be blue at first, and we wouldn't have any parents because we haven't traversed this whole thing yet, right? So we don't know who the parents are, and as we haven't gone to any one of the nodes, that's why all of them are blue. Blue meaning that they haven't been visited yet. So let's write that down so it's easier to understand. So blue means not visited or unvisited, whatever you like. So anyway, so we would have another variable which is called time, that would keep track on what time we're entering the stack and whatnot. So we are done with this for loop, which is mainly for initializing the arrays and putting the values, and the time variable we talked about it. And so let's get on to this one. So for each vertex, we're gonna check the whole thing. So for each vertex, let's say we start with 1. So is the color of 1 blue? Yes, it is blue. So we pass 1 here, and this goes back to this function. So in recursion we remember, like, so one function calls another one, which calls another one. So when we are done with this one, we go back here, we go back here, and so on, right? So we have to keep track who calls whom. So we go here and make the color of 1 gray. So let's make it gray. Then time plus 1. So time was initially 0, we cut that, and plus 1. Okay, so du time, so discovery time would be 1. We put 1 here, and normally if you traverse the array, just not looking at the code, we would see 1, this would be 2, this would be 3, this would be 4, right? So, and from 4 we can't go anywhere else. So 5, this would be 6, this would be 7, and this would be 8. These all represent 1, 2, 3, 4. So hope you guys did understand that. Anyway, so for each vertex adjacent to u, so u is 1 here, right? So we have 2 and 4 which are adjacent to 1. So we enter into this loop and we see, check if the color is blue. So let's say we are going in a sequence, so 2 then 4. So let's look at 2 first. So is 2 blue? Yes, 2 is blue. So we make the parent of 2 1. So from the graph here we can actually see the parent of 2 is 1. So we put 1 as the parent, and then this whole function is called again, thus the recursion process is going on. So 2 comes here, u is 2 now, so we make 2 gray. So gray means that the whole we are actually working on that particular node. We made 2 gray. Now time plus 1, so this is going to be 2. So we put 2 here because of the discovery time. Then we look at the adjacent nodes of 2. So the adjacent node of 2 is 3. So we put 2 as the parent of 3. So we put 2 here. I'm sorry, this would be 2 here, and then we call the recursion function again, where we are gonna put 3. So 1 called 2, 2 now is calling 3, right? So 3 comes back here where u is 3, so we are gonna gray out 3. Okay, so time plus 1, so this becomes 3. So this is actually following this pattern, right? The one that we looked before. So 1, 2, 3, and let's see if it's 4 or not. So 3, so the discovery time would be 3 here for each vertex adjacent. So we have adjacent 1 and 4, but 1 is discovered. Anyway, so we are gonna go through all of this, right? So you're gonna check the adjacent. Let's say it's 1. Is the color of 1 blue? No, we don't work in this. We go back and check if the color of 4 is blue. Yes, the color of 4 is blue. So we are gonna pass 4 here, which goes back to the whole process again, and now we're gonna gray out 4. So 4 is gray now, and time plus 1, so this would be 4, and discovery time would be 4. Oh, I forgot one thing. So it says to assign the parent, so the parent of 4 would be 3. Anyway, so then we're gonna go to for each vertex adjacent to 4. So does 4 have any adjacent vertices? No. So you're not gonna go through this whole process, and we're gonna go here where we are gonna black out 4. So black means that we are actually completely done with that particular node, and we increase the time. So this is gonna be 5 now. So you can see 5 here as the ending time. Now we're gonna go back. So who called 4? So 1 called 2, 2 called 3, 3 called 4. So we are done with 4 now, right? So we're gonna go back here, go to 3. So we were in this loop, right? So does 3 have any adjacent nodes? So we can't go to 1. We are done with 4, so it doesn't have any adjacent nodes. We come back into this spot in the line number 8, and we black out 3, meaning we are all done with 3, and we increase the time to 6. We see the ending time being 6 here. Okay, so who called 3? 2 called 3. So we go back to 2. So does 2 have any adjacent nodes here? So it had 3 only, but we are done with 3, so it doesn't have anything else. So we don't do all this process here. So we go back here, we make 2 black. Okay, now we increase the time by 1, so 7 here. So we have 7 at the ending, and we go back. So who called 2? 1 called 2. So we go back to 1. So we worked with 2, right? The adjacent of 1. So we are done with 2, and we only have 4. But is the color of 4 blue? No, it's not blue. So we're not going to consider this, and not going to go into this loop. So we are done with, we come here and we make 1 black and increase the time by 1, which is 8 here. Now if we had another node, let's say we have 5 here. So what would happen is that when checking for 2, we are all done, and we are all done with 4. We're gonna go back. We see there's another node, right, which is 5. So we put 5, like the parent of 5, as 1, and let's say 5 was blue, and the discovery time for 5 is time plus 1, so this is going to be 8. And now we are gonna go back to the whole method again and do all the process. So 5 is gonna be gray now, and time plus 1, so this would be, so it was 7 then, so it would be 8 now. so that would be its discovery time. So discovery time would be 8 here, and for each vertex adjacent, so 5 doesn't have any adjacent vertices, right? So we don't go through all this process and we black out 5 because we are all done with 5, right? Then we increase the time by 1, which would be 9. This would be the ending time of this. We go back and we see that 1 doesn't have any more adjacent nodes that are unvisited, so we black out 1, increase the time by 1, so 10. So this would be 10 would be the ending time of 1. So this was the whole process. So this is really interesting and fun. So I hope you guys did understand something. Try to do this whole simulation on your own, and take smaller like graphs to easily understand what's going on here. And so hope you guys did like the video, and if you have any questions or suggestions, please comment down below, and thanks for watching.